is right angled triangle. So in this way we have proved that this the example which is based on the distance between two points. In this way we can also ask to prove that these vertices are the these points are the vertices of the equilateral triangle. So in that way we can also prove that if we find AB, BC and AC, if all sides are equal, then it is proved that these vertices are, this triangle is equilateral triangle. So in this way we can find the distance between any two points, and we can use to prove using the types of triangle. Any kind of example we can prove based on this kind of example. In same way, if we ask to prove about the quadrilaterals, then also we can first let us discuss about the different types of the quadrilateral, and then we will discuss about the example based on the types of quadrilateral. So let us look at first the types of quadrilaterals. Types of laterals. Okay, so first of all we have parallelogram. પેરેલોગ્રામ નો મતલબ શું થાય? સમાંતર બાજુ ચતુષ્કોણ, એટલે કે કેવો? જેની સામે સામેની બે બાજુ સરખી હશે, એટલે કે જો A, B, C અને D એક ક્વાડ્રિલેટરલના કોઈ શિરોબિંદુ હોય, that means the A, B and C, D are vertices of any quadrilateral. Then if AB is equal to CD and AC is equal to, and BC is equal to AD, then that is known as parallelogram. Okay, so here first of here for the vertices A, B, C and D, here if AB is equal to CD and AD is equal to BC, right? That means the opposite sides are equal. AB is equal to CD and AD is equal to BC, then this quadrilateral is known as parallelogram, right? In the same way, if we want to prove that the vertices with the rectangle, what is the properties of rectangle? Then in the same way here opposite sides are equal, that means AB is equal to CD and AD is equal to BC. Moreover, in addition to this one, if AC is equal to BD, that is the diagonals of that quadrilateral are equal and the opposite sides are also equal, then we can say that this quadrilateral is rectangle. Okay, so if opposite sides are equal and the diagonals are also equal, then we will say that this is the rectangle. In the same way, for the rhombus means સમબાજુ ચતુષ્કોણ. rhombus નો મતલબ થશે સમબાજુ ચતુષ્કોણ, એટલે કે એવો ચતુષ્કોણ કે જેની ચારે બાજુઓ સરખી હોય. તો if here AB is equal to BC is equal to CD is equal to AD, then that is known as rhombus. That means આવો જે ચતુષ્કોણ છે એને શું કહેવાશે? સમબાજુ ચતુષ્કોણ, કે જેની ચારે બાજુઓ સરખી હશે. આ જ રીતે જો તમને ચોરસ વિશે પૂછે, that means about the square. So for the square, if AB is equal to BC is equal to CD is equal to AD, એટલે કે ચોરસની પણ બધી સાઈડ સરખી હશે, આપણે બધાને ખબર જ છે. મોરઓવર, જો વધારાના જો એના ડાયાગોનલ્સ પણ સરખા થાય, that means AC is equal to BD, then તે ચતુષ્કોણ છે એને આપણે શું કહેશું? ચોરસ કહેશું. That means the quadrilateral with the all sides equals and the diagonals are equals, then that is known as a square. So here AB is equal to BC is equal to CD is equal to AD, and AC is equal to BD. So these are the main types of quadrilaterals. So example based on these types are frequently asked in the GTU exam. So we have discussed about the types of the quadrilaterals. Now let us discuss about the example based on the types of quadrilateral. So if we look at the example, a question is using distance formula so that -1 3 -1 3, second point is 2 6, third point is -4 0, and 5 3 are vertices of a rectangle. So here we need to prove that these points are vertices of the rectangle. એટલે કે આપણે એવું સાબિત કરવાનું છે કે આ ચારે બિંદુઓ છે એ લંબચોરસના શિરોબિંદુઓ છે. સો લંબચોરસ સાબિત કરવું હોય તો પહેલાં આપણે બધી સાઇડ, સો ફર્સ્ટ ઓફ ઓલ લેટ denote, that is A -1 -3, B that is 2 6, C with -4 0, and D with 5 3. And now let us find the distance between all sides of that quadrilateral. So here AB square is equal to, here AB, that is 2 minus -1, that is 2 plus 1 whole square, that is x2 minus x1 whole square, plus 6 minus -3, that is 6 plus 3 whole square, that is 2 plus 1, that is 3 square, that is equal to 9, plus 6 plus 3, that is 9, and 9 square, that is 81. So the answer is 90. So here AB square is equal to 90. In the same way, if we find the BC square, here B is equal to 2 6, and the coordinates of C are -4 0. So distance between B and C, that is y2 x2 minus x1 and y2 minus y1. So -4 -2 whole square plus 0 minus 6 whole square, that is equal to -4 -2, that is -6, and -6 square, that is equal to 36. Also here 0 minus 6, that is -6 square, that is equal to 36. So 36 plus 36, that is equal to 72. So we have AB square is equal to 90 and BC square is equal to 72. In the same way, if we find CD square, that is here C, the coordinates of C are -4 0, and the coordinates of D, that is 5 3. So distance between CD and the square of CD, that is 5 minus -4, that is 5 plus 4 whole square, plus 3 minus 0 whole square, that is here. Okay, so this is 5 plus 4, that is 9 square, that is equal to 81, and 3 minus 0 is equal to 3, and 3 square, that is equal to 9. So 81 plus 9, that is equal to 90. And in the last, we will find the distance between A and D. So if we find AD square, here A here and D is here, so we will find AD square, that is equal to 5 minus -1, that is 5 plus 1 whole square, plus 3 minus -3, that is equal to 3 plus 3 whole square. So 5 plus 1, that is equal to 6, and 6 square, that is equal to 36, and 3 plus 3, that is 6, and 6 square is equal to 36. So that is 72. So here AB square is equal to 90, BC square is equal to 72, CD square is equal to 90 and AD square is equal to 72. So here we get that here AB square is equal to CD square and BC square is equal to AD square. So that means AB is equal to CD and BC is equal to AD. So opposite sides are equal, but here we need to prove that these are the vertices of right angle triangle. If you these are the vertices of rectangle. So for the rectangle we need to prove that the diagonals are also equal. So we need to find the value of diagonals. That means here we need to find AC and BD as well. So let us find AC square. So here AC square is equal to, here this is A and C, so minus 4 minus 1, that is minus 4 plus 1 whole square, and plus 0 minus 3, that is 0 plus 3 whole square. So minus 4 plus 1, that is equal to minus 3, and minus 3 square, that is equal to 9, plus 0 plus 3, that is equal to 3, and 3 square, that is equal to 9. So this one is equal to 18. In the same way, the second diagonal is BD. So let us find BD square. So here B and D is here. So that is 5 minus 2. So 5 minus 2 whole square plus 3 minus 6 whole square. So 5 minus 2, that is 3. 3 square, that is equal to 9. In the same way, 3 minus 6, that is minus 3, and minus 3 square, that is equal to 9. So that is also equal to 18. So we get AC square is equal to BD square, implies AC is equal to BD. So after all we have got that. આપણે શું મળ્યું તો કે આ ટ્રાયેંગલ માટે, આ ક્વાડ્રિલેટરલ માટે AB is equal to CD and BC is equal to AD. That means opposite sides are equal, and moreover the diagonals are also equal, that is AC is equal to BD. So using all these three, we can say that if AB is equal to CD, BC is equal to AD, and AC is equal to BD, implies this is the A, B, C and D are vertices of a rectangle, right? So in this way we can also use the distance formula. If you note that in all these type of example we have only used the distance formula, and more than that the types of triangle, types of quadrilateral that we have already learned in the our previous 9th 10th. Okay, so आपने बधाने एक ख्याल ज छे के ट्रायंगलना प्रकार केवा होय, चतुष्कोणना प्रकार केवा होय. तो ए जो प्रकारोना मात्र तमने प्रोपर्टीज ख्याल होय तो ए प्रोपर्टीज अने डिस्टन्स फॉर्म्युलानो यूज करी आ प्रकारना एक्जाम्पल आपणे इजीली सॉल्व करी सकीए. सो आ बधा एक्जाम्पल छे GTU एक्जामने लईने खूब ज महत्वना छे ऑल. सो आ बधा प्रकारना एक्जाम्पल उपर आपणे खास ध्यान देशुं. वधारामां सर्क्युम सेंटर उपरना एक्जाम्पल पण आ चेप्टरमांथी खूब ज महत्वना छे. तो आपणे खूब ज झड़पथी सर्क्युम सेंटर विषे पण वात करशुं. सो लेट अस डिस्कस अबाउट द सर्क्युम सेंटर ऑफ अ ट्रायंगल. सो what do you mean by the circumcenter? The circumcenter is the intersecting points of the intersecting point of all the, if I saw here, then if we take the perpendicular bisector of all here, this is the perpendicular bisector, this is the perpendicular, and this is the perpendicular bisector. So the crossing point of, or the intersecting point of all perpendicular bisector, that is known as the circumcenter. Or I can say, if I draw the circle here, which is passes through all these 3 points of the triangle. Then the here if I say this is the P, then P is the circumcenter of the triangle, then we can say that here PA is equal to PB is equal to PC, because this is PA, PB and PC is the radius of that circle. So here P is the circumcenter of this triangle, and if P is a circumcenter, then we can say that PA is equal to PB is equal to PC, that is known as circumradius. Okay, that is circumradius. So if we ask any example which is based on the circumcenter, then we need to use this idea, this property, that if P is a circumcenter of the triangle ABC, then PA is equal to PB is equal to PC. So using that idea we can solve the example basis on the circumcenter. Let us quickly look about on one example which is based on the circumcenter. Then if the question is like that, if 1 0 is a circumcenter of a triangle with vertices x3 minus 2 4 and 3 root 21, then find x. Okay, if 1 0 is a circumcenter of a triangle with vertices x3 minus 2 4 and 3 root 21. So let us denote the circumcenter, that is P 1 0, vertex is A, that is x3, B, that is minus 2 4, and C, that is 3 root 21. If P is the circumcenter of this triangle, then PA is equal to PB is equal to PC. So let us find PA, PB and PC. So here PA square is equal to